Ankita, roll number 4, roll number 4, roll number 5, 6, 7, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
Yes, sir.
Okay. 19, 20, 21, 22, 23, 24.
Present, sir.
24 is present.
Yes, sir. Shubham.
Shubham. 1 minute. I have not called your name. 1 minute. 24, 25, 26, 27, 28. Shubham is present. 29, 30.
Present, sir.
Okay. 31, 32, 33, 34, 35. Manjunath. 36. Pratmesh. Joslino. Soham. Atiya. Shweta.
Present, sir.
Okay. Deepa.
Present, sir.
Okay. Hanumant. Ilyas. Prajwal. Pratmesh K. Karthik Patil.
Present, sir.
Okay. Sohel. Sohel. Rohit Mutagi. Sridhar Patil. Vishal. Sampath.
Present, sir.
Okay. Srishal. Abhishek.
Present, sir.
Okay. Anybody else?
Sir, 01, sir.
07. Okay. Anybody else? Right. Screen is visible?
Yes, sir.
Okay. Yesterday I was discussing about the series fed class A amplifier. The AC power delivered to the load is RC. This is the load here in this circuit. This is a load resistance RC or RL. We can consider either it as a RC or RL, right? The power that is delivered to this load, right? That is nothing but the AC power delivered to the load may be expressed as or written as P naught AC is equal to VCE RMS into IC RMS. It is the product of voltage and the current. VCE RMS, that is RMS voltage, collector to emitter voltage, multiplied by collector current RMS, that gives the AC output power. That gives the AC output power. Okay. AC means we know that it is the RMS value. Right? So RMS voltage multiplied by RMS current, that gives the AC output power. Now AC output power, now this VCE is nothing but V, I can write it as, right? How can I write V? So V is equal to I into R. According to Ohm's law, V is equal to I into R. Now this VCE RMS, I can write it as IC RMS into RC. Correct? VC RMS, I can write it as VCE RMS is nothing but it is equal to IC RMS into as ICRMS into RC. VCRMS is equal to ICRMS into RC. Then what we'll get here? ICRMS into RC into ICRMS. ICRMS into RC into ICRMS. That will be equal to ICRMS into ICRMS will be IC square RMS into RC. Right? Therefore, AC output power is equal to IC square RMS into RC. RC is the load resistance. Okay. V is equal to I into R, and hence I into I is I square. Therefore, AC output power will be IC square RMS into RC. Take it as equation 6. Now, this I can express it as V by R. I can express it as V by R. Okay. According to the Ohm's law, if I rearrange the terms, then I can write the equation as IC RMS is equal to VCE RMS this divided by RC, V by R. Okay, V by R. Now, if I substitute I as V by R or IC RMS as VCE RMS by RC, then what equation will get next? I is equal to V by R. Just substitute that in equation 5. So VCE RMS into VCE RMS, that will be VCE square RMS, that divided by RC. That is, AC output power is also equal to VCE square RMS divided by RC. Take it as equation 7. Okay. That means AC output power is given by V into I. It is also given by I square R, or it is given by V square by R. Okay. Accordingly, this it is VCE RMS into IC RMS, or IC square RMS into RC, or VCE square RMS by RC. Okay. Next, let us use the peak values or the maximum values. We know that RMS value is given by Vm by root 2. What is the equation for RMS? RMS voltage or RMS current is given by, so VRMS is given by Vm divided by root 2. VRMS is equal to Vm divided by root 2. Divided by square root of 2. Okay. So this is the equation. VRMS is equal to Vm by root 2. Now, if we substitute this VRMS is equal to Vm by root 2 here, then we will be getting VCE RMS, that is nothing but VRMS, that is equal to VCE peak or maximum, VCE peak divided by root 2. VCE RMS is equal to VCE peak divided by root 2. Similarly, ICRMS. Next for ICRMS, ICRMS is equal to IC peak or IC maximum divided by root 2. Correct? VRMS is VM by root 2, IRMS is IM by root 2. Accordingly, I am writing VCRMS is equal to VC peak by root 2, or ICRMS is equal to IC peak by divided by root 2. Peak is nothing but the maximum value. Now, if we use these relations in equation 5, suppose if we put these equations in equation 5, it is VCE RMS is equal to VC peak divided by root 2 and IC RMS is equal to IC peak divided by root 2. Then what we will get? The equation will be VCE peak divided by root 2 into IC peak divided by root 2. That will be P naught AC, AC output power. That is VCE peak into IC peak in the numerator. In the denominator, root 2 into root 2. Root 2 into root 2 is how much? How much is root 2 into root 2? Yes. How much will be root 2 into root 2? 2, because root 2 into root 2 is square root of 4. So square root of 4 is 2. Yes or no? Square root of 4 is 2. So therefore, this will be equal to VCE peak into IC peak, that divided by 2. Take it as equation 8. Now we know that VCE peak is nothing but IC peak into RL. VCE peak, it is nothing but the collector current maximum value into the load resistance or into RC. Both are one and the same. Either we can take it as RC or RL. So VCE peak is equal to IC peak into RL or RC. Therefore, IC peak will be equal to, rearrange the terms, IC peak will be equal to VCE peak divided by RL. I am rearranging term for IC peak. IC peak will be equal to VC peak divided by RL. Now let us use these equations in equation 8. Whatever equation we got now for VCE peak or IC peak, let us substitute those equations in equation 8. If we substitute those equations in equation 8, then we'll get AC output power P naught AC is equal to, right? VCE peak, what is the equation? Final equation, P naught AC is equal to VCE peak into IC peak divided by 2. Yes or no? That is, P naught AC will be equal to IC peak. What is IC peak? It is VCE peak divided by RL. IC peak is VCE peak divided by RL. Substitute that. Therefore, this will be equal to VCE peak into VCE peak, that is VCE peak square or VCE square peak, that divided by RL into 2. Correct? Because IC peak is VCE peak, substitute that here. So IC peak is VCE peak by RL. So VCE peak into VCE peak, that will be VCE square peak, that divided by 2 RL, that divided by 2 RL. Take it as equation 9. Is it clear here how we got this? I am substituting for IC peak into equation 8. If we substitute this IC peak is equal to VC peak by RL in equation 8, right, in this equation, then we'll get P naught AC will be equal to VC square peak divided by 2 RL. Right? Let us number it as equation 9. Similarly, what is VCE peak? VCE peak is IC peak into RL. Correct? One more equation is VC peak is equal to IC peak into RL. Substitute that. VC peak is IC peak into RL. So if you substitute that, what we will get? IC peak into IC peak. That is I square C or IC square peak into RL, that divided by 2. Correct? VC peak is IC peak into RL. Substitute that in equation 8. That is IC peak into IC peak. It is IC peak square into RL. Into this RL will come, that divided by 2. Okay. Take it as equation 10. Fine. Now let us use peak to peak values. Let us use peak to peak values. If we use peak to peak values, then VCE peak to peak, VCE collector to emitter voltage peak to peak, that is 2 times VCE peak. Okay. Now what is meant by peak to peak? Peak to peak, suppose if we consider this waveform, suppose if I consider this waveform here, right, what is meant by peak to peak voltage or peak to peak here? From this portion, positive peak to negative peak of the AC signal, that is called as peak to peak. The positive portion to negative peak portion, from there to, from positive peak portion to the negative peak portion, that is called as peak to peak. Now this peak to peak is half of the, if you want only half, that is VCE peak. That is nothing but peak to peak divided by 2. Yes or no? I want only half portion, so that is peak value. So if I want only the peak value, that is peak to peak that divided by 2, that will give me the peak value or the maximum value, that is half. Correct? So it is VCE peak is equal to peak to peak is equal to 2 times VCE peak, or VCE peak is equal to VCE peak to peak divided by 2. Similarly, peak to peak current, that is given by IC peak to peak is equal to 2 times IC peak. Whatever is for the voltage, the same is for the current, because both are sine waveforms. Both are sinusoidal waveforms. We have IC peak to peak is equal to 2 times IC peak, or IC peak is equal to IC peak to peak that divided by 2. That divided by 2. Correct? Now, if we use these equations in equation 8, if we substitute these equations in equation 8, what is equation 8? This is our equation 8. P naught AC is equal to VC peak into IC peak that divided by 2. In this equation, if I substitute these peak to peak values, right, that is VC peak is equal to VC peak to peak divided by 2, and IC peak is equal to IC peak to peak divided by 2, then what we will get? See, what is the equation? P naught AC is equal to VC peak into IC peak that divided by 2. So what is the equation we have? P naught AC, P naught AC is equal to VCE peak, VCE peak, sorry, VCE peak into IC peak, IC peak, this divided by 2. This divided by 2. Now what is VCE peak? It is VC peak to peak divided by 2. VC peak is VC peak to peak divided by 2. And IC peak is IC peak to peak divided by 2. Substitute that. Therefore, we get P naught AC, P naught AC. This is equal to VCE peak to peak, VCE peak to peak, peak to peak divided by 2, right, into, let us write it later, this into IC peak to peak, IC peak to peak divided by 2. Okay. So we are dividing 2 times. One is VC peak to peak divided by 2 and IC peak to peak divided by 2. So in the denominator, what we get here? 2 into 2 multiplied by this 2. Whatever already 2 is there, that 2 multiplied by this 2. So what it will be? The equation will be VCE, VCE peak to peak, okay, into IC peak to peak, into IC peak to peak, peak to peak. Any problem? Any problem there? Yes? Okay. VC peak to peak into IC peak to peak, that divided by 8. This divided by 8. This divided by 8. Okay. So this is the equation that we are getting. That is equation that is written here. So it is VCE peak to peak into IC peak to peak divided by 8. Fine. Let us number it as equation 11. Now equation 9 can be rewritten as let us go back and see what is equation 9. P naught AC is equal to VC square peak divided by 2 RL. V naught AC is equal to VC square peak divided by 2 RL. So again, we have to express peak in terms of peak to peak. The equation is P naught AC is VC square peak divided by 2 RL. P naught AC is equal to VC square peak divided by 2 RL. VCE square VC square peak VC square peak divided by 2 RL. This divided by 2 RL. Fine. Now what is VCE peak? It is peak to peak divided by, correct? This is the equation that is there here. P naught AC is VC square peak by 2 RL. VC square peak divided by 2 RL. Okay. Let us express VC peak as VC peak to peak divided by 2. VC peak is VC peak to peak divided by 2. So it will be, this is further equal to, so VC peak is nothing but VC peak to peak divided by 2. So it is VC peak to peak divided by 2 means VC peak to peak square divided by 4. Correct? Square it. VC peak to peak divided by 2 square. So VC peak to peak divided by 2 square, that is VCE peak to peak square this is square, this divided by 2 RL. This divided by 2 RL. Now VC peak to peak divided by 2, it should be divided by 2 square. Okay, that divided by 2 RL. So this is further equal to VC square peak to peak divided by 4. VC peak to peak square divided by 4. Square VC peak square right, VC peak to peak square, this divided by 4, this divided by 4, so 4 into 2 RL, that will be 8 RL. So this divided by 8 RL in the denominator. So it will be VC peak to peak square divided by 8 RL, that is AC output power. In terms of peak to peak voltage, it is VC peak to peak square divided by 8 RL. Okay, that is, it is mentioned here. P naught AC is equal to VC square peak to peak divided by 8 RL. Similarly, if we substitute for IC peak to peak is, so what is the equation here? IC, that is, if we consider equation 10, okay, if equation 10, this is our equation 10, P naught AC is equal to IC square peak RL divided by 2. So IC peak is IC peak to peak divided by 2. Correct? IC peak is IC peak to peak divided by 2. That will be IC peak to peak square divided by 4 into RL by 2. IC peak to peak square divided by 4 into RL by 2. That means it is IC peak to peak square RL divided by 8. IC peak to peak square into RL divided by 8. Correct? Because IC peak is IC peak to peak divided by 2. So IC peak to peak divided by 2 square it. It will become IC peak to peak square divided by 4 into RL divided by 2. So it will be IC peak to peak square into RL divided by 8. Correct? That is the equation it is mentioned here. P naught AC is equal to IC square peak to peak into RL divided by 8. Number it as equation 13. Okay. Now let us write peak to peak in terms of the maximum and minimum value. Using maximum and minimum values, VCE peak to peak. I hope you are following here, students. Any doubts up till now? Any doubts up till now? Yes. Any doubts up till here? Shweta? Shweta?
No, sir.
Okay. Deepa? Deepa?
No, sir.
Okay. Abhishek? Abhishek?
No, sir. No, sir.
Any problem up till now?
No, sir.
Okay, fine. Shubham? Bekwadkar? Shubham? Sagar? Talikeri? Sagar? Sania? Sania? Mahadev? Mahadev Wadeyar? Prajwal Mali? Prajwal? Ilyas? Ilyas? Karthik Patil? Karthik?
Equation number 8.
Equation number 8 you have doubt? Okay.
Yes, sir.
Okay. Fine. See, equation number 8, let us go back and see what is equation number 8. P naught AC is equal to VC peak by root 2 into IC peak by root 2. Okay. So what is equation 8? How we are getting this? What is the main equation? P naught AC is equal to VC RMS into IC RMS. This is the main equation. VC RMS into IC RMS. Correct? IRMS is IM by root 2 or IP by root 2.
That means
IRMS
सर डिवाइड बाय 8 है देखो
किधर
और एक 9 का 10th वन है इक्वेशन
10th equation 1
10
11th
डिवाइड
one
बाय हाँ इधर
11th equation
हाँ डिवाइड बाय 8 कैसा है
हाँ बोलता हूँ P naught AC is equal to in equation 8 we have to consider equation 8 right what is the equation 8 just see here equation 8 is P naught AC is equal to VC peak into IC peak divided by 2 okay P naught AC is equal to VC peak into IC peak by 2 okay okay next now what equations we are using here so the equations that we are substituting here are these equations that is VC peak is equal to VC peak to peak divided by 2 right and IC peak is equal to IC peak to peak divided by 2 we are substituting in this equation 8 VC peak as VC peak to peak divided by 2 and IC peak as IC peak to peak divided by 2 समझ में आ गया तो VC peak to peak divided by 2 into IC peak to peak divided by 2 डिनोमिनेटर में क्या आ गया 2 into 2 into 2 VC peak to peak divided by 2 into IC peak to peak divided by 2 correct yes or no so in the numerator what you are getting VC peak to peak into IC peak to peak in the denominator 2 into 2 into this 2 already which is there
Uh,
Followed
yes,
here. So it will be VCE
uh,
peak to peak into IC peak to peak divided by 8.
yes, sir.
Got the point? Okay,
Yes, sir.
fine.
Yes.
Any
Thank you, sir.
other doubt, Karthik?
No, sir.
Okay, fine. Good. Now let us use the maximum and minimum values. VCE peak to peak, this is given by maximum value of collector to emitter voltage minus the minimum value of collector to emitter voltage. And peak to peak collector current is maximum value of collector current minus minimum value of collector current. Let us see how we are getting this. Peak to peak as this minus this, and peak to peak current as this minus this. This is our collector current waveform that we discussed yesterday, collector current waveform. Fine. Now the maximum is this, IC max it is, the maximum positive peak, and the negative peak is IC minimum. It is IC minimum. Therefore, IC maximum minus IC minimum, that gives the peak to peak value for the collector current. Right? The maximum value minus the minimum value, that gives peak to peak value of the collector current. Fine. Similarly, for the collector to emitter voltage, this is the minimum value, the negative peak. The positive peak is the maximum value. Therefore, maximum value, that is positive peak, minus the minimum value, that is negative peak, that gives the peak to peak voltage. That gives the peak to peak voltage. Getting the point here? So VCE max minus VCE min, that is VCE peak to peak. Similarly, the collector current IC max minus IC min or IC minimum, that is IC peak to peak. Following here, that is what it is written. VCE peak to peak is VCE max minus VCE min, and IC peak to peak is IC max minus IC min. Now let us use these equations 14 and 15 in equation 11. What is equation 11? P naught AC is equal to VCE peak to peak into IC peak to peak divided by 8. This is the equation. In this equation, if we substitute, then what we are getting? What is VCE peak to peak? It is VCE max minus VCE minimum. IC peak to peak is IC maximum minus IC minimum, that divided by 8. Simple. Okay. VCE peak to peak is VCE max minus VCE minimum. IC peak to peak is IC max minus IC minimum, that divided by 8. That is what is written here. P naught AC is equal to VCE max minus VCE min into IC max minus IC min, that is IC peak to peak, that divided by 8. Clear here? You understood here how we are getting? VCE peak to peak, this is VCE max minus VCE min. IC peak to peak is IC max minus IC min, that divided by 8. Fine. Take it as equation number 16. Now maximum AC output power, we are calculating maximum AC output power from equation number 16. How to calculate the maximum AC output power? When the power will be maximum, the output power AC will be maximum when VCE min is 0, when this minimum value of VCE is 0 and maximum value of VCE is VCC. And the current minimum, IC minimum is 0 and maximum collector current is VCC by RL. This point I discussed in yesterday's class. That is the limit of the collector current and the collector to emitter voltage waveforms. Now, if I consider this collector current waveform, the maximum limit that it can change with the changing input signal is from 0 to VCC by RL or from 0 to VCC by RC. Correct? That is the maximum. So, minimum value of the collector current IC minimum is 0. Maximum value is VCC by RC or VCC by RL. That is a maximum for the collector current. Then for the collector to emitter voltage, as the input signal changes or increases, the collector to emitter voltage increases, but it has certain limits. What is the limit? The lower limit is 0 volts, and the maximum limit is VCC. Here, this point that we are taking for drawing the DC load line. Correct? It is the VCC, that is maximum value, minimum value is 0. So it is in between 0 to VCC. Right? That is what we have to consider here. So VC minimum is 0, VC maximum is VCC, IC minimum is 0, and IC max is equal to VCC by RL or VCC by RC. Now, if we substitute these values in equation 16, then we'll get VC max is VCC, VC minimum is 0. So VCC minus 0 is VCC. IC max is VCC by RL, IC minimum is 0. Therefore, it will be VCC by RL minus 0, that divided by 8. That divided by 8. Then we will get the equation as, if we substitute these, that is VC max is VCC, IC max is VCC by RL, it will be VCC into VCC by RL, that is VCC square by RL, and then in the denominator we have 8, therefore we will get VCC by 8 into VCC by RL, that will be VCC square divided by 8 RL. Okay, the maximum AC output power we'll get when we have V maximum and I maximum in the numerator, and that is obtained when the VC minimum is 0 and VC maximum is to the maximum value VCC, and IC minimum is 0 and the IC maximum value is VCC by RL. So when both V and I are maximum, the output power will be maximum because the numerator will be maximum, and hence the AC output power will also be maximum. Therefore, we'll get the equation P naught AC max as VCC square divided by 8 RL. Okay, let us number it as equation number 18. Okay, this is the maximum AC output power that we are getting from the series fed class A amplifier, that is VCC square divided by 8 RL. Right. Take this example, students. We'll solve one small example. Note down this example. Any difficulty up till here in the derivation?
No, sir.
These steps are clear, right? Fine. Okay. Note down this example. A class A series fed power amplifier is required to deliver a maximum power of 20 watts to a load of 4 ohm. Calculate the required supply voltage. A class A series fed power amplifier is required to deliver a maximum power of 20 watts to a load of 4 ohms. Calculate the required supply voltage. Note down the statement of the problem. Note it down, students. Did you all note down? I hope you noted down the statement. Just note down the statement of the problem. So what is given here? It is clear that it is class A series fed power amplifier, and it is delivering a maximum power of 20 watts to a load of 4 ohms. So RL is 4 ohm or RC is 4 ohm. Then maximum power, it is maximum AC power that is delivered. Okay, maximum AC power output, because the input power is, we are having the VCC.
AC.
So it is input power is a DC, VCC that we that I explained yesterday. Right, output we are getting the AC power. Correct, because when we are applying the DC voltage, first the input signal, the AC signal is 0. Correct, getting the point here. The AC signal we are maintaining it 0 first when we are applying the DC voltage. We are applying only the DC voltage first. So the input power is DC. Try to understand here. And what AC power we are getting is when we are applying the input signal. When we are applying the input signal, right, when we start to apply the input signal, then whatever output we are getting, that is the AC power. Got the point here? So it is the maximum AC power. Just now we have written the equation for maximum AC power, that is P naught AC max. This is equal to VCC square divided by 8 RL. P naught AC max is equal to VCC square by 8 RL. Okay, that is the equation. P naught AC max is equal to VCC square by 8 RL. P naught AC max is given, it is 20 watts AC maximum output power. Therefore, VCC will be equal to square root of 8 into P naught AC max into RL. VCC will be equal to square root of 8 into RL into P naught AC max. Then substitute the values. Square root of 8 into P naught AC max is 20. Then RL is 4 ohms. So square root of 8 into 20 into 4. Calculate how much it will be. Square root of 8 into 20 into 4. Tell me the answer. Calculate and tell me. Square root of 8 into 20 into 4. How much you are getting, students? Yes. What is the answer? Square root of 8 into 20 into 4.
226.2.
Let us check. 25.29 volts you will get. See, square root of 20 into 4 is 80. 80 into 8 is 640. So square root of 640 is how much? 25.29 volts. Correct? Yes or no?
Yes, sir.
25.29
That
volts.
one
Okay.
slide
Just
to
check your answers. Huh. This is square root under
25.29.
whole square root it is. Square root of 8 into 20. 20 into 4 is 80. 80 into 8 is 640. So square root of 640. It will more than 25 only because 25 square is 625. So you'll get around 25.29 volts. Right. So this is how we are
Yes.
calculating the supply DC voltage VCC. Fine. So did you all understand, dear students, today's topics? So what all we discussed in today's topics? We started with the basic equation, that is P naught AC is equal to VC RMS into IC RMS, right? Then we expressed in terms of current and voltage. Then using the peak values, we expressed the RMS value in terms of maximum value. It is VRMS is equal to VM by root 2. Based on that equation, we expressed VC RMS and IC RMS. Then later, we rewritten the equation P naught AC as VC peak into IC peak divided by 2. Further, V is equal to I into R based on the Ohm's law, and rearranging the terms, I is equal to V by R. Right? Using these relations, again we rewrote the equation number 8 as P naught AC is equal to VC square peak by 2 RL, and P naught AC is equal to IC square peak into RL by 2. Then using the peak to peak values, peak to peak voltage, that is VCE peak to peak is 2 VCE peak, or VCE peak is VCE peak to peak by 2, and IC peak is IC peak to peak by 2. Using these equations in equation 8, the basic equation, it is P naught AC is equal to VCE peak into IC peak by 2. After substituting, we'll get P naught AC as VCE peak to peak into IC peak to peak divided by 8. Then again, the equation is rewritten, equation number 9, this equation, right? By substituting in terms of peak to peak voltage and peak to peak current, we'll get, if we substitute that, as P naught AC is equal to VC square peak to peak by 8 RL, and P naught AC is equal to IC square peak to peak into RL by 8. Then later we consider the maximum and minimum values, that is VC peak to peak as VC max minus VC minimum, IC peak to peak as IC max minus IC minimum. Then we substitute this in the basic equation number 8, that is this equation. So after substituting that, then we'll get the equation as P naught AC is equal to VC max minus VC min into IC max minus IC minimum, that divided by 8. The maximum AC output power is obtained when the V is maximum and I is maximum. That is, V will be maximum when VC minimum is 0 and VC maximum is maximum, that is VCC, and IC minimum is 0 and IC maximum is maximum, that is VCC by RL. After substituting these values into equation 16, then we'll get P naught AC maximum is equal to VCC square by 8 RL. Okay. So memorize these equations and know the derivation, and accordingly memorize the equations also. And we solved an example on the maximum AC output power, okay, where we found out the value of the DC supply voltage VCC. Is it understood, students? Today's topics. Today's topic, is it clear? Abhishek?
Yes, sir. Clear, sir.
Okay. Srishal? Sampath? Sampath? Is it understood, Sampath? Sampath? Karthik?
Yes, sir. Understood.
Understood? Fine. Shweta?
Yes, sir.
Shweta? Clear with the topics, Shweta?
Yes, sir.
Okay. Deepa? Deepa?
Yes, sir.
Clear with the today's topics, Deepa?
हाँ sir, yeah, all cleared.
Okay, fine. Shubham? Bekwadkar? Shubham? Shubham?
Yes, sir.
Understood, Shubham? Today's topics? Any problem in understanding?
No, sir.
Okay. Sagar? Sagar? Mahadev? Mahadev Odear? Mahadev? Okay. So in the next class, we'll solve one or two examples, right? And then we'll start with the transformer coupled amplifier, class A amplifier that we'll take up in the next class. Thank you.